Hi there, and this is the video on increasing and decreasing functions and looking at the first derivative test. So far we've been doing a lot with identifying the behavior. We've looked at critical numbers, and we know that we've talked a little bit about the fact that when the derivative is negative, the function's decreasing, and when it's positive, we know it's increasing. So what we're going to do is kind of formalize a lot of that today. So our objectives in this video are: number one, determine intervals on which the function is increasing or decreasing, and number two, apply the first derivative test to identify relative extrema. That's what really happens with that first derivative test. We're going to start out by taking a look at a couple of definitions. The definition of what it means to be an increasing or decreasing function. And in this case, to be an increasing function, what it means is for any two numbers, x1 and x2, in an interval, if x1 is less than x2, then f of x1 would be less than f of x2. In other words, when I have a smaller number, when I put a smaller number into a function, I will get a smaller value out. So x1 is smaller than x2, f of x1 is smaller than f of x2. Now a function will be decreasing on the interval when for any two numbers x1 and x2 in the interval, x1 less than x2 implies f of x1 is greater than f of x2. In other words, when I put smaller numbers into the function, I will get larger values out. That's what it means to be a decreasing function. And so what we have is tests for increasing and decreasing functions. If f prime of x is greater than 0, for all x in the interval from a to b, then f is increasing on the closed interval from a to b. Number two, if f prime of x is less than 0 for all x in the open interval from a to b, then f is said to be decreasing on the closed interval from a to b. And finally, if f prime of x equals 0 for all x in the interval from a to b, then f is said to be constant on that closed interval from a to b. Now we get to what's called the first derivative test. Now you might need to pause the video here to go and try to write everything down, but I'll go through it a couple times. We're going to let c be a critical number of a function f. So c is going to be a number that when I take the derivative of f, I get 0 or it's undefined. And f is going to be continuous on an open interval I containing c. If f is differentiable on I, except possibly at c, because remember, c is a critical number, so it could possibly be the fact it could be a critical number because it's the derivative is undefined there. So that's why it may not be except possibly at c. Then f of c can be classified as follows. If f prime of x changes from negative to positive at c, then there is a relative minimum at c f of c. So if I put numbers that are smaller than c into the first derivative and I get negative values out, and then I put numbers that are bigger than c into the first derivative and I get positive values out, then I know there's a relative minimum at c f of c. So I know that function was decreasing until it got to c and started increasing after c. Number two, if f prime of x changes from positive to negative at c, then there is a relative maximum at c f of c. And that's going to be for the same reason, that if I put numbers that are smaller than c in, I know that the derivative would be positive, so the function's increasing. And then when I put in values that are bigger than c in, the derivative comes out to be negative, so I know it's decreasing. So I had to reach a high point at c. And if there is no sign change at c, in other words, when I put numbers to the left of c into the derivative, I get positive, and when I go to the right, I get positive, or if I get negatives in each case, then we don't have a relative max nor a relative min at x equals c. So how do we go about determining relative extrema? Well, we're going to let f of x be continuous on our open interval I. So the first thing I have to do is find all critical numbers in I. The critical numbers are going to break I into subintervals. Okay, and those subintervals, on those subintervals, I know my function is going to be either increasing or decreasing. Number 2, I'm going to identify a test value in each subinterval and evaluate f prime of x at that test value. So it doesn't matter what I pick, I just have to pick one number in each subinterval. And whatever is true about that value is going to be true about every value in the subinterval. So if I plug that number in and I get a positive, every value in the subinterval would give me a positive. The third thing I have to do is identify if f is increasing or decreasing or constant on each subinterval. And that's just going to be based on what happened when I evaluated f prime at that test value, if I got a positive, negative, or 0. And once I have that, I'm really going to just go and apply the first derivative test. So now let's take a look at a problem. Here's an example. We have f of x equal to x cubed plus 3x squared minus 45x plus 17. So the first thing I have to do is find the critical values. And to find the critical values, I have to identify where my derivative is going to be 0 or undefined. Well, since I'm dealing here with a polynomial, with real coefficients, this thing is not going to be undefined. It is going to be the only critical numbers are going to happen when we are at 0, when the first derivative is 0. So I take my first derivative and when I just go through using the power rule. So I know f prime of x comes out to be 3x squared plus 6x minus 45. Now I notice in this one that I can pull out a factor of 3 to make my numbers smaller. And when I do that, I get 3 times x squared plus 2x minus 15. Then that's a basic quadratic that does factor nicely, so I get 3 times the quantity x plus 5 times the quantity x minus 3. And so looking at that, I know that will be 0 when x is negative 5 or positive 3. So I have my critical numbers are negative 5 and 3. So my polynomial here is defined. My original polynomial, f of x, is defined for all real numbers. So I know that these two critical values are going to break my number line up into 3 intervals. My subintervals are going to be from negative infinity to negative 5, negative 5 to 3, and then 3 to infinity. Now what I have to do is just identify test values for that subinterval. Now I can pick whichever numbers I want. I can use numbers that are close to negative 5. Like in the first one, I could use something that's close to negative 5, or I could use something that's farther away. I tend to try to keep things as small as possible. So in this case, my first test value, since I'm just going to use a negative 6. In my second interval, negative 5 to 3, one of the things I noticed there is that I went from a negative to a positive, and so 0 is a value in that interval. So if I can use 0 as a test value, I'm going to use it. So I'll put 0 right here. And the next one I have is a number bigger than 3, so I'm just going to choose 4. Those are some nice numbers I can work with. Now, what I have to do is I need to determine the sign of f prime of x. So what I'm going to do that, I'm going to take my test value, in this case negative 6, and I'm going to put it into the x's in the factored form. So what I notice on this, when I take negative 6 and put it into x plus 5, that's going to be negative. And when I take negative 6 and put it in for x in the x minus 3, that will also be a negative value. And so what will happen is I will get a 3 times a negative times a negative. Well, if I take a positive times a negative, I know I'm going to get a positive result. So therefore, the sign of f prime of x when we use negative 6 is going to be positive. And so therefore, I know that f of x is increasing on that interval from negative infinity to negative 5. So it's increasing. So now we go to our second test value. In this case, we have 0. So I put 0 in for the x's. I get 3 times 5 times negative 3. Well, the result there is that's going to give me a negative. And so therefore, I know we are decreasing. Okay, and then when I go and put 4 in for x, that will be a positive 3 times 9 times 1. So I get a positive times a positive times a positive, and I know I'm going to get a positive result. And so this now is, I know it's increasing from 3 to infinity. So therefore now, I have this set up. I know from negative infinity to negative 5 that this power of this function, f of x, is increasing. It's decreasing from negative 5 to 3, and then increasing from 3 to infinity. Therefore, by the first derivative test, I know I have a relative max at x equals negative 5, x equals negative 5, and I have a relative min at x equals 3. To actually find the maximum minimum values, I would need to plug negative 5 and 3 in for x, and I will leave that up to you. So this now concludes our video on how to use on the first derivative test. So we'll talk a little bit more about it in class, and then we'll work on the problems that that are listed on the assignment sheet. So have a good evening, and we'll see you in class.